A very warm welcome to all of you. Myself, Professor Nagri SS from Department of Chemistry, KJ Somaya College, Koparagaon. In today's lecture, we are going to start the next chapter from the syllabus, that is the chapter number 2, Nuclear Chemistry. This is the second chapter from the syllabus. In this lecture, we are going to study the introductory part from this chapter, as well as one important concept, that is the classification of nuclides. Before starting this lecture, please subscribe my YouTube channel and press the bell icon in order to get the notification for the upcoming video lectures. So let's start this lecture. As far as the nuclear chemistry is to be considered, we have to study in this chapter the study related to the nucleus of an atom. So we are interested to know about what is meant by atom, what is the constituent of the atoms. The atom consists of two important parts, a nucleus and outer sphere. Nucleus consists of protons and neutrons. The protons are positively charged while the neutrons are neutral in nature. Overall charge on nucleus is always positive. The atom, we know very well that consists of the two important parts, nucleus and outer sphere. Nucleus consists of protons and neutrons. Protons are positively charged, neutrons are neutral. So the overall charge on a nucleus is positive. The proton and neutrons collectively called as the nucleons. The collective name for the protons and neutrons are nucleons. The outer sphere consists of electrons having negative charge. The nucleus of hydrogen only consists of proton. This is only the exception in a periodic table. This hydrogen element has only the proton, it does not have the neutrons. The radius of nucleus is in the range of 10 to the power minus 13 centimeter. It is the range of a radius of a nucleus. The number of protons and electrons are equal, so atom is neutral in nature. As far as the number of protons and electrons are to be considered, they are always equal in number, so that the overall charge on any atom is equal to 0. We can say that the atom is a neutral in nature. This is a simple introduction regarding the atomic structure of an element. Next, we have to study some simple concept related to the nucleus of an atom. The first simple concept is atomic number of an element. It is denoted by alphabet Z. The number of protons in the nucleus of an atom is called as the atomic number. It gives us an idea regarding the number of protons. The next important concept is a mass number denoted by the capital A. The sum of protons and neutrons present in nucleus of an atom is called as mass number. This is a summation of protons and neutrons present in the nucleus, which is given by the simple equation A is equal to Z plus N. Here Z stands for proton number and N stands for the neutron number. The atomic nucleus without its corresponding outer sphere is called as nuclide. As far as the atomic nucleus is considered, if we consider only the nucleus, irrespective of the surrounding part, that is spherical part, which is called as the cells surrounding the nucleus, then that individual nuclear part is called as a nuclide. In this chapter, we are going to study only the nuclides of an element. The simple examples of nuclide are nuclide of carbon with atomic number 6, mass number 12. Next is a nuclide of nitrogen, atomic number 7, mass number 14. Once we study the simple introductory part for the nuclear chemistry chapter, next we have to study classification of nuclides. As far as the classification of the nuclides is considered, this classification is based upon the two different bases. On the two different basics, we have to classify the nuclides. The first basis is on the basis of number of proton and neutron of the nuclide. How this nuclides can be classified on the basis of number of protons. So let's look one by one. The first classification consists of the important concept called as the isotopes. And this is the first type of the nuclides. Now, what is by isotopes? The nuclei of the same element having same atomic number but different mass number are called as the isotopes. Now, as far as the isotopes are to be considered, they are made up from the same element but they have the different mass number. So, if the nuclei of a same element having the same atomic number but different mass number, then that nuclei are called as the isotopes of each other. As far as the examples are considered, we consider here isotopes of sodium, that is sodium having atomic number 11. So in each these three nuclei, atomic number is a constant having a 11 as an atomic number, but as far as the mass number is considered, first sodium has the mass number 22, second having the 23, and the third having the 24. So we can say that these three nuclei of a sodium having same atomic number but different mass number, so they are called as isotopes of each other. The second simple examples of isotopes are isotopes of the uranium having common atomic number 92 and having different mass number as 233, 235 and 238. The second important type of the nuclides is isobars. The nuclei of neighboring elements having same mass number but different atomic numbers are called as the isobars. Now these isobars having the definition exactly opposite to the isotopes. In this case, the nuclei of a neighboring elements we have to consider which having the different atomic number but same mass number. So let's study the simple examples. Example of carbon and nitrogen. The carbon having atomic number 6, mass number 14, while the nitrogen having the atomic number 7 and mass number 14. So you can say that they having a same mass number but different atomic number, so they are called as the isobars of each other. The second simple example is nuclei of a sodium and nuclei of a magnesium having same mass number but different atomic number, so they are called as isobars of each other. Now in this isobars we have to study one more concept, that is a mirror nuclei. What is by the mirror nuclei? The isobaric nuclei in which the value of Z and N, that is a value of proton and neutron, differ by 1 from one another and interchange their position are called as the mirror nuclei. So first of all, these mirror nuclei are nothing but the isobaric nuclei in which what happens, the number of protons and number of neutrons differ by the one from one another and they exchange the position, so that they are called as the mirror nuclei. The simple examples is here nuclei of carbon and nuclei of nitrogen. First of all, they have a same mass number, so we can say that they are isobars of each other. The carbon has the atomic number 6 while nitrogen has the atomic number 7. But now if we look towards the number of protons and number of neutrons, in the carbon number of protons is a 6 while number of neutrons is a 7. On the other hand, in a nitrogen the number of protons is a 7 and number of neutrons is a 6. So we can say that these numbers of protons and neutrons get interchanged or exchanged in these two nuclei, and so we can say that these isobaric nuclei are called as the mirror nuclei. The second important example is that of the nuclei of a sodium and magnesium. In this case also, number of protons and neutrons get exchanged between these two nuclei, so it is called as the mirror nuclei. The third important type of nuclides is isotones. The nuclei contains the same number of neutrons are called as the isotones. Whenever the nuclei consisting the same number of neutrons, they are called as isotones. The simple examples are nuclei of a carbon and nitrogen. They are isotones. Now why they are isotones? So if we look towards the number of neutrons, in this case in a carbon nuclei the number of neutrons is equal to 7, while in this nitrogen nuclei the number of neutrons is again equal to 7. So we can say that as number of neutrons are equal in number, so they are called as the isotones. The second simple example is the example that is a nuclei of a sodium and magnesium having equal number of neutrons, so they are called as the isotones of each other. The fourth important type of these nuclides is isomers. The nuclei having same atomic number and mass number but different energies are called as the isomers. Now in this case, both the nuclei having a similar atomic number as well as mass number, but one content is a different, and that is nothing but the energy content. These two nuclei get differ in case of the particular energy, so we can say that they are the isomers of each other. And one more important thing is that these elements or these nuclei are made up from the same element. They are from the same element. The first important example is for cobalt nuclei having mass number 60. In this case, these are the two nuclei of a cobalt, first having 60, m, while the second is only 60. The second example is that of the bromine with mass number 80, and the second case, the again bromine with mass number 80. Now in this case, one alphabet is used, that is a small m. The nuclei having higher energy are called as radioactive and are unstable in nature, denoted by m. Now in this case, what happens? The two nuclei of a cobalt is there and two nuclei of bromine is there. One nuclei having, or it is denoted by the small m. So whenever a nuclei having a higher energy, it is called as radioactive in nature and it is unstable in nature. So that unstable state of a nuclei can be denoted by the alphabet m. M stands for metastable state. So this m is a metastable state. So we can say that among these two nuclei of a same element, one nuclei is present in a metastable state, second present in a ground state. Whenever a nuclei is present in a metastable state, it is unstable in nature. It becomes stable by emitting the excess amount of energy and it get returned to the ground state, and that's why it becomes stable. So we can say that no doubt these two nuclei are made up from the same element having a similar mass number, but only they have the different amount of the energy, and so these nuclei are called as the isomers of each other. So these are the four different types of the nuclei depending upon the number of protons and number of neutrons. Now the next classification of this nuclei is on the basis of stability. On the basis of stability, the nuclides are classified into two important types. One is a stable nuclides and second is called as unstable nuclides. Now what is by stable and unstable? So let's look towards their definition. The nuclei which are permanently stable, whose proton and neutron contents remain constant, are called as the stable nuclides. So whenever the stable nuclides are to be considered, they are permanent, or we can say that they are permanently stable, having a constant proton neutron contents are called as the stable nuclei. The simple examples are nuclei of oxygen having atomic mass number 18. So all these are called as the stable nuclei whose proton neutron contents remain constant. The second important type is a unstable nuclides. The nuclei which are highly unstable and continuously emit radiations of high energy, whose proton neutron contents change spontaneously with the time, are called as unstable nuclides. As far as these unstable nuclides are to be considered, they are unstable in nature. And why they are unstable in nature? Because they continuously emit the radiations of high energy, and that's why their proton neutron contents continuously change and they are converted from one nuclei into the another nuclei. So they are called as the unstable nuclides. These nuclei are also called as the radioactive nuclei. These nuclei continuously emit the radiations, that's why they are called as the radioactive nuclei. On the other hand, these stable nuclides are also called as the non-radioactive nuclides. Now, the examples for these unstable nuclides or radioactive nuclides. So let's study these simple examples. Uranium, this is a well-known example of radioactive nuclei. This uranium having atomic number 92 and mass number 235. Second nuclei of uranium is again mass number is 238, atomic number 92. So these are the two important classes of the nuclei on the basis of the stability, stable nuclides or non-radioactive nuclides, and the second one is the unstable nuclides or radioactive nuclides. So in this lecture, we start the second chapter from the syllabus, nuclear chemistry, in which we study the simple introductory part regarding the constituents of the nucleus of an atom, the simple definitions, atomic number and mass number. In the second part, we look towards the classification of the nuclides on the two different parameters. The first one is depending upon the number of protons and neutrons, and second on the basis of stability. So with this, I stop here. Remaining portion we will study in a next lecture. Thank you so much.